Hey everyone, in this video I'll show you how to verify a trigonometric identity, and I'll talk about a couple important things to keep in mind. One is that you'll only work one side of the identity, and you want to pick the more complex side and work on it till it looks like the simpler side. The other guideline is change everything to sines and cosines and then start simplifying from there. It's also helpful when you're first working on these, if you don't have all the basic identities memorized yet, to have a sheet of notes with that information. For example, the Pythagorean identities, the reciprocal identities, the double angle formulas, possibly the half angle formulas, but these three up here you're going to use really often. And also this one here, tangent of x equals sine of x over cosine of x, because when you're converting everything to sines and cosines, you'll want to have that as well. So let's tackle this problem. We will work this one side, the more complex side, and we'll change everything to sines and cosines. So our numerator, we change from secant squared x to 1 over cosine squared x. And our denominator, we will change from tangent of x to sine of x over cosine of x. So we have a complex rational here, and we can rewrite that as a division problem since every fraction bar means division. So we can rewrite that as 1 over cosine squared x divided by sine of x over cosine of x. So like any fraction division or rational division problem, we can change it to multiplication by the old method of keep it, change it, flip it. So 1 over cosine squared x times cosine of x over sine of x. And now we can do some cross-canceling in this direction, because cosine of x goes into itself once, and it goes into cosine squared, just leaving with a one factor of cosine x there. So rewriting that, we get 1 over cosine of x times 1 over the sine of x. And now using those basic reciprocal identities, we can replace this with secant and this with cosecant, leaving us with secant x, cosecant x, which is exactly what we wanted to achieve in our verification. And so this problem is done.